the Jim Channel podcast, bringing you the big picture on geoscientific information management through interviews and discussions.
Welcome to the Jim Channel. Our podcast channel features guest speakers from the natural resources industries, with an interest and focus on digital technologies and geoscientific information management. If you're enjoying our podcast series, please leave some feedback through your podcast player or on Apple Podcast. We love to hear from our community.
Thank you, everyone, for coming and joining the this year's panel discussion for the Acquire booth. Let me know at the back if you can't hear me okay. I'll try and speak a little louder. But I'm Warren Carvey. I'm the operations manager here in North America for Acquire. If I haven't met any of you, feel free to come find me after and say hi. Today's panel topic, as you can see from the screen up there, is smarter data for smarter decisions. And I'll just read a little summary question or paragraph here, and then I'll introduce the panelists and pose the first question. So the summary question goes like this. There's been an explosion of data being generated in mining as companies navigate deeper mines and are exploring increasingly complex ore bodies. Managing these larger volumes of data to access, analyze, and then confidently make smarter decisions from the data is becoming increasingly challenging. Our guest panelists are invited to discuss these challenges and how technology plays a critical role in miners making smarter decisions with smarter data. So I guess first on the panel, I'll start at the far end. We've got Chris Hunter. He's a senior resource geologist for Centerra Gold. Chris is a safety-focused senior mine engineer and consultant for almost 30 years. He's worked in copper, gold, zinc, oil sands, frac sands, and in mining camps in the Porcupine, Red Lake, Flin Flon, Snow Lake, McMurray, and Quesnel regions. He's utilized multiple mining softwares for block modeling, estimation, and database management. Next, we've got Jennifer MacLachlan from Cameco. She's the Exploration Information Management Manager. Jennifer has degrees in geological engineering and GIS and has been working in information management at Cameco for nearly 10 years. She oversees exploration's data silos, including drill data in Acquire's Jim Suite, 2D and 3D spatial data, geophysical data, land data, images, and documents. And then closest to me here, we've got John McGaughey, president at Mira Geoscience. John holds a PhD in geophysics from Queen's University. His focus is on 3D and 4D data management, earth modeling, and interpretation for mineral exploration, mining, and geotechnical hazard assessment. Mira Geoscience is a software and services company with offices in Canada and Australia. So now you've met the panel. I'll pose the first question. Maybe I'll start with Chris on the far end again. Lucky you. First question, more and more data is becoming available for miners to use. Are you seeing new sources of data adding to this? And if so, what are they?
At our mining operation, we're not seeing necessarily new data, but increased volumes of data. And that's a very large concern for our operation, is the management and being able to actually physically handle and have enough time to understand and interpret the data in your mind with the large volumes. We're drilling upwards of 100 holes a day, and we sample those holes. We get multi-element analysis done on all those holes, so we have so much information to work from. It becomes time consuming, and the reason we pushed to get Acquire for the operation side was being able to handle all that data.
Jennifer, any comments?
I think some of the new data that we're finding these days is more of the not as precise stuff, like trying to get information from images, drone footage, that sort of thing. So things that you might need more help sort of interpreting, not just easy point data or numbers or things like that, but stuff that's a bit more hard to pin down.
Right. John, from your perspective at Mira, any comments?
Right. So we do see different, lots of different kinds of data through both exploration and the mine site itself. In terms of new data, yeah, there's always new stuff coming along. Exploration recently, I've seen, passive seismic data or muon tomography or whatever. There's always new gizmos creating new data sets. That's true on the mine site as well. We're dealing with a lot of new kinds of ground deformation data, new kinds of sensors. But at the end of the day, the real issue is how do you get all that data into one place where you can do something with it, combine that data to get some value out of it. So the challenges that I see are not so much in new data types coming along. New data types are welcome. I think we can always handle them. It's not that hard to find structures to handle them. It's really how do you combine new data sets with existing data sets, and that's really, for us, is always the challenge.
Yeah, that actually leads me to my next question, which was, what are the biggest data management challenges you have around these larger volumes of data? So, sure, and go ahead. Sure, Chris.
Yeah, well, it's interesting that as you want to increase your data set, you always have a senior leader that is saying, well, is it worth the cost? You have to justify it. You just can't collect the data and then not do something with it and show a value for it. An operating mine has strict budgets that we have to follow, and it's important that you can distill the data quickly and show the value that it's going to make an improvement somewhere that will lower cost, increase productivity, increase safety. Any of those key benchmarks, the KPIs that the managers are really going to look for.
Yeah, in terms of data volume is a huge issue. I wouldn't say in mining we have a real big data problem like you might in particle physics or something like that, but we still have voluminous amounts of data, and there's a real data heterogeneity issue, and this gets back to the issue I mentioned earlier of the challenges of combining data. So on the exploration side, you might combine a 3D seismic data cube or INSAR data or very densely spaced LiDAR data with drill hole data. And how do you get that data together? And how do you hold it in one place, in one data warehouse, so it can be brought together? And the kind of solutions that we found are to make sure we're able to mix and match things like relational data structures, proper SQL data tables for things like drill hole and geochem data, with smart file-based data with compression and proper tags and labeling for really large data sets like LiDAR or 3D seismic, so you can still pull out the parts of the data you need and combine it with other data within the same system. And those are the kinds of challenges that we've been working on over the last few years, and they just get more challenging as more large data sets come in. So yeah, the data volume issue is an issue because you want to combine it with things like drill hole and sample data like you have in Acquire, and how do you do that? That's the challenge.
Right. Jennifer, you've got diverse data background.
Yeah, I think a lot of the problem, and I suppose it's even a problem with small amounts of data, but particularly with big amounts of data, you've got all the quality control involved. So is your data, odds are your data is not all in one place. So when you bring it together, is it corresponding to the rest of the data? Do you have some overlaps? Do you have things that are different in one place from the other? And how do you deal with it? How do you keep up with that instead of having to go back and look at things from the past? That happens all with old data now because we've digitized it from who knows where, so we don't know if it's right or wrong or what it corresponds to. So I would say with more volume, you've got more of that quality issue, and I think you have to spend more time working on that and making sure that the stuff that you're collecting is high quality data that you can rely on to make your decisions. Otherwise, it's not really useful.
Yeah, quality data, smarter decisions.
And accessibility is key. It's if you can't get to the data and use it and have your understanding of the data, across, like for Centerra Gold, we work across multiple countries. We have mines and all around the world, but we still keep our processes the same between the mines, so that if we ended up sharing staff, they would recognize the workflows throughout.
Good. Just circling back to the main topic here. Next question, maybe I'll pose it to you, Jennifer. When we talk about smarter data and making smarter decisions, what does this mean to you, and how does this look in your business?
Smarter data, I think, probably starts with how we collect the data. So is there a way we can have a more automated collection system, not having people have to enter things more than once or even enter them manually? Do we have sensors? Do we have ways that we can bring stuff right into the database without any human interaction? So just taking out that possibility for error when you're capturing the data, I think, is a big thing. And we're seeing more things like that, like more downhole probes that can read different things and can actually, take pictures of the rock or of what's left when you take out the core. So I definitely think having that, having the more automated capture, I think, is a big part of getting smarter data, and then making sure that you're capturing what you need to make those decisions. So not just grabbing everything you can, but making sure you really focus on what the important data is that you need to make your decisions.
Right. Why you're grabbing that data.
Yeah, why you're grabbing it and what you're going to use it for. So we could get, 5,000 fields, but are we going to use them all?
Yeah.
Are we just going to waste time putting them in and trying to figure out what they are? Or are we just going to get the 2 or 3 that we need and that we need to make the decisions?
Chris, you're nodding your head down there.
Yeah, it's interesting how fast bad data can wreck a project, can wreck your model. It's, what is that funny little piece of data sitting out there? What does it mean? But if you have it managed at the front end, it's so much better. It allows you to think this could mean something, right? This outlier,
as opposed to somebody typed an extra 0 in or something.
Yeah. John, what are your thoughts on the smarter data, smarter decisions?
Well, in terms of smarter data, data's not smart. What your ability to use data smartly, depends on being able to access the data you want in a timely manner and have that data validated so you can trust it. So, our approach is to, where we can, get data that is, properly QC'd and validated from systems like a Acquire system for drill holes and samples, but to also make sure across the breadth of data types that data has consistent metadata and tagging, so that when you want to bring different types of data together in some kind of multidisciplinary integration, you're able to get the data, the basic data sets, primary data sets together quickly, and you're able to access the right version of the data, and you're not wasting 90% of your time, which you typically do in these projects, on just finding and fighting for the data that you want. So to me, smarter data means ways to access the data that you need for your project across all the disciplines quickly, and be able to trust that data so you can trust your analysis going forward.
Right. And another question for you. I'll start with John on this one. What is the current industry trend towards technologies like AI, machine learning, and what are your thoughts there?
Sure. So we at Mira Geoscience, we do a lot of work in AI and machine learning, and I suppose we're part of that trend, which is, it's in part a buzzword. People are wondering what they can do with AI, and everyone wants to know if machine learning can be applied to their problem. The trends that we're seeing is that a lot of that initial part of the hype cycle is now getting resolved down to some useful tools. And those useful tools are across a wide range of issues in exploration and mining, whether it's preventive maintenance at the mine site, or whether it's looking at hyperspectral data in exploration, or looking at drill hole data. But the one thing that hasn't really changed, and I'll get back to this again because it's what we specialize in at Mira Geoscience, is the data integration part of it. So machine learning is getting pretty good at doing smart things with grids in exploration, with block models maybe for metallurgy, with drill holes, On the mining side, it could be, I mentioned preventive maintenance. So, the engine on the scoop tram, looking at that, or the tires. The thing that all of those things I mentioned and many more that I didn't mention have in common is they all have a single support. So you're working with multiple properties, say in the grid cells of a 2D grid or the blocks of a block model, or multiple properties on different engines you're looking at on a scoop tram or something like that. So those are better controlled problems because you're looking at, again, multiple properties on a common support. The harder problem, and it's the one that we've really tried to devote ourselves to, which I don't think has seen a lot of general progress in the industry, although I think we're making some headway, is how do you combine these different things? How do you take an airborne gravity survey and combine it with drill hole data or soil geochemistry data when those are on really fundamentally different supports, even though it's the same project area and you want to use those different data sets for your exploration targeting? How do you get those different data sets together using some of these tools like machine learning or AI to do something smart that will lead to better drill hole targets? So I haven't seen a heck of a lot of progress in that other than what we've been doing within our company. And we've made some, I think, really good strides. But generally across the industry, what I've seen is a lot of progress on single problems with single supports.
Right. So it's changed. I mean, the follow-up question was, how has it changed in the last 5 years? So I think it's changing, but maybe slowly or gradually.
Well, I think it's changing in that there were some really good tools. You see really good examples. There's always papers published at conferences like these of, cool things people are doing with machine learning to, better, say, normalize lithologies in hundreds or thousands of drill holes using comment fields or whatever. We do that kind of work as well. Or combining multiple geophysical inversions on the same support, or multiple different properties on 2D maps or 2D grids for targeting. You see a lot more of that. So that's the trend. Those tools are getting better, and we're really seeing a lot of good examples and good papers published and good case studies. I'll just get back to the harder problem, the one that we've really focused on. I think made some good headway is how do you combine, sparse drill hole data with, an airborne geophysical coverage, which is, so the data in exploration and mining, very heterogeneous, sparse data. It's not regularly sampled. How do you deal with those problems? Those are the problems that are really still for the future in large part. We're making headway on those, but you don't see a lot published on that kind of stuff.
Right. Jennifer, thoughts on machine learning, AI?
It's
Other
definitely coming up in the world. I guess I'd say maybe in the last probably almost 5 years, maybe 3 or 4 years, it's sort of come to my attention a bit more. I think, like John said, it's a matter of combining it with your other data. So you may be learning about something, analyzing something with machine learning or with an AI, and then how do you take that information, how do you make sure you get that information out in a way that you can use and combine with your other information? So, for instance, things like getting information from a image of core. So they might be able to detect certain things, but then how do we say how it detected that? Like, how do we put that data out so that we combine it with other downhole data when it's just, I don't know, maybe a coordinate and a data point from the program. So getting that information, I would say getting the information, the tool is definitely useful, but then getting that information out and combining it with the other information is probably the bigger issue, I would think.
Yeah. Chris, thoughts? Other trends as well? Machine learning, AI?
Truthfully, in the mines, I haven't seen that yet. We deal in breaking rock, which is, rather clunky, but, I'm all for it. I'm admittedly a little worried my job's going to be taken by Skynet, but, I'm all for it, though. I want to retire someday.
Yeah. Fair enough. Maybe I'll go Jennifer here. What role is technology playing in one of the biggest topics right now, ESG?
I would say that it is making it easier to, I guess, respond to those issues that come up. from that sort of thing, making sure that you have the data to show that you are, if it's something like environmental, that you're following regulations, that you're focused on that as you're collecting the data, and that you're collecting data related to that, and just that you can have the data that you need to make the decisions that you need to make on those topics, basically, and make them in a smart way with data that you know is reliable.
Chris, thoughts?
Yeah, for sure. The mines, we are under a very, very stringent regulatory framework, and collecting the data and presenting it how the regulators want to see it. Right? They usually have a very specific, formatted way they want to get the data, the way it interprets. So it's not just what we can do; it's what the customer, the government agency wants. Especially when it comes to environmental considerations. It's very important to give them what they want to, essentially to keep them happy, so they can understand what you've given them right away.
Yeah. John, anything to add there? I want to jump on to the next question.
Well, look, I think some of those things, particularly safety and environmental, the objectives we have can be better reached by proper quantitative data integration across the disciplines. We've seen that. We do a lot of work on geotechnical safety. So we've got our data integration platform, Geoscience Integrator, in mine sites, where it's bringing data in directly from microseismic systems and ground deformation systems, combining it with geology and other production data, blasting data. And it's only when you get all of those data types together in the same place at the same time can you do really smart things with it in terms of safety. So everyone's known for years that all of those different kinds of data that I mentioned and more have some impact on mine safety, whether it's roof fall or rock burst or whatever the safety issue is. But how do you actually pull those together quantitatively? It's one thing to know it qualitatively and to make reasoned sort of expert judgments. That certainly has its place. That's the way it's always been done. But we've actually demonstrated in many occasions that you can take those data sets together quantitatively, apply things like machine learning, and come up with better assessments of hazard. Probabilistic assessments show that they're quantitatively have value. We've seen their predictive capacity in operating mine sites. The same thing will apply to tailings, right? When you have tailings failures, there's multiple kinds of data that go into that, right? And it's by combining all of those data sets into some kind of probabilistic framework that you can actually do something smarter with the data to get back to your original decision. So it's a tough problem. How do you take data, again, that's sparse, heterogeneous, and validation issues? A lot of it still is not even digitized in mine sites. It's hard to believe maybe, but we do work where we need to ask people to get blasting data, blasting records out of filing cabinets, that kind of thing. Still happens all the time. But once you have the capability of pulling those kinds of data sets together, you can actually do something much smarter with it. And that is right from production to these sort of ESG issues.
Yeah. I saw a lot of heads shake when you said paper copies of data there, and a few nods in the audience.
Yeah. Oh yeah. Well, in exploration, we still. I mean, most people obviously are on GIS systems or whatever, but we see paper maps all the time, pencil crayon. I mean, it's
also things like mine grids and weird random things like that.
Yeah, absolutely. Yeah, absolutely. If you want to understand the history of ground support at a mine, which we often needed to do in our work, it is very difficult. You're looking at a project perhaps of months while people go back through records, back through old AutoCAD drawings to try and figure out what the ground support they had installed in place over time was. And if you want to do smart things with data, you need to understand what the evolution of the ground support was. And if it's that tough to find, it is just that much tougher to apply these smarter analytical methods.
Right. Yeah.
It is interesting. Like one of the mines I worked at earlier in my career in Timmins, Ontario, was it was started in the 20s, and
Sure.
and there was everything was stored in a vault, written on mylar and paper, and just over the generations they had to keep increasing the technology in order to keep up with the mining and where they wanted to go. But that is our industry. A lot of the places we work, they're there for decades and decades. So you have to be able to grow and scale up accordingly.
And the reality is today, whether it's a mine site, a mine office, or an exploration office, across the industry, the most common thing that we see in terms of data is a few isolated databases like Acquire or some other specific databases. But it's usually, everyone's got a drill hole database, it seems. And there are a few other kinds of databases around for different kinds of data. But most data today is not on paper or mylar, but it's on a network file system buried in nested subfolders. And it is very, very difficult to get value out of that data unless you pull it out of there and put it into a data warehouse where you've got common tags and metadata and an ability to get things on a common coordinate system. And it's only then that you can do these sort of data fusion operations that actually pull those different kinds of data together onto a common support. If you want to do any kind of machine learning or AI, you need that. And it's actually a pretty sorry state in the mining industry across the board. A network file system for managing data, that's not smart. Okay? That's not what I call smart data. That's data, it's not smart data.
Amen.
Preaching to the choir.
Yeah. I think at this point, we'll probably just open it up to that was great, by the way. We'll open this up to questions from the audience. If somebody has a question, put your hand up. Just wait, I can bring the mic to you, and you can ask the panelists. So, hand up, anyone? Who's going to be brave and go first? Paul, you're twitching your fingers over there? Anyone?
Just do SharePoint with your network files.
Nope.
My comment.
No SharePoint.
No
Was the comment.
No SharePoint. Yeah, agreed.
Yeah. I guess I have a question that I wrote earlier for myself, all by myself. Do you think the industry's attitude towards data management in general and its value has changed in recent years? Let's go, Jennifer.
Slowly, I would say.
Slowly changing?
Slowly, but yes.
It's improving?
Improving, definitely. You got to drag the old school people along with you and convince them and show them that, they can get everything they want out of a dashboard or something, as long as you have the data in there and digitized and managed properly.
Yeah, sometimes it's a slow uptake because when somebody builds an Excel database, if you want to call it that, or a Windows file system database, people get comfortable with it, and then you have to justify, right? Why do we need to spend money to buy and acquire a system, right? It's working the way it is, but you get to a point where you get so much data, and in Excel you reach the 2 gig limit, and then your data falls apart. What do you do? It's only when the oh my gods happen, right? That change really takes place.
Yeah. As they say, Excel is where data goes to die.
Good point. Any other questions at all? Anyone? Go ahead.
Going back on what you were saying about data and organization structure and whatnot, my understanding is that geologists and engineers and whatnot, we know how to use the data, but we don't know how to organize it. That's been kind of proven with all of these mines and whatnot. Universities lately have been rebranding and reorganizing their librarian degrees to be metadata specialists or knowledge managers and whatnot. And are we seeing departments hire librarians instead of geologists and engineers to really work on reorganizing the metadata and preparing it so that the language across the board is the same, so that everybody knows how to use it properly? Is that something that we're starting to see or not?
I haven't seen it yet, but that has been my first and ongoing request for new staff at the mine, would be somebody that to manage the different data systems and the data within them. very valid.
It sounds like a good idea. I think there's still that belief, whether proper or improper, that it helps to have the knowledge of what the data is that you're working for. So to have a bit of that geological knowledge if you're dealing with geology data. But I definitely think there could be more of a focus on the data management and knowing the best practices and how to do that properly. So, either getting a geologist and teaching, or getting a librarian and teaching them a little geology, or teaching a lot more data management to geologists, I guess. So,
I would say in every case where our geoscience integrator data warehouse system is being deployed, ultimately someone has been put in charge of that, and that is either outsourced back to us if the customer doesn't want to do it themselves, or it's done by somebody. Somebody gets appointed to that role, and it's usually a geologist or geophysicist. And I do think you need the domain knowledge to do that. So I think I would be more likely to train a geologist or geophysicist, if you could convince one to want to do this, to take on that role, than to try to teach a librarian geoscience or mining. Yeah. But the role is required, absolutely. Yeah.
Good. Well, thanks for the question, and thanks very much to the three panelists. If you want to give them a round of applause, I think Chris, Jennifer, John.
Thanks for listening to Acquire's podcast, The Jim Channel. Find us at acquire.com.au.